you have a system or an assembly that is a part of a bigger system or a bigger assembly, in this case it is important to identify the relationships between the systems and their internal assemblies and the surrounding assemblies and the environment that they're operating in. So every interaction should be carefully considered for past problems and the previously unseen phenomena. Then you include the notes of the conditions, phenomena, timing of the event for future reference. Like you say, in the past, I used to have a noise that will show up on a certain speed. I used to have an intermittent operation at a certain voltage, at a certain current, and so on. So you put those as part of the root cause analysis so that it will help you preventing that from happening again in the future. And in your DRBFM worksheet, you put those past problems in the references tab so that you can use them in order to prevent those from showing up in your new design. Then you eventually, of course, seek in the inputs from the experienced members. And this way you can look at the big picture and identify all possible relationships and all possible future causes that could show up in your system. Developing a problem statement or developing a story. How do we do that? As we are building our DRBFM worksheet. So of course you go through the change point list and you go through the function list, and you already did the visualization and you reached already to the change matrix or the change points cross functions matrix that we talked about before. That's where you will look at your interacting areas of concern and identifying all your potential and confirmed concerns. So in this case, interacting area of concern, what is the area of concern? Here the problem statement will be you have a failure phenomenon and your subject will be the parts and components. So you have parts and components in here interacting with the functions of each part in here. Then you're identifying in your change matrix all possible or confirmed concerns. Then you say, what is the failure phenomena for this? Then I put my notes and I will reference or cite in our references tab what are those concerns are in more details, and how does that failure or that concern showed up. Then you say you can describe when and where in terms of part life, in terms of area of part that applied to that specific concern. So in short story, you're trying to be as specific as possible in developing your problem statement. That's where you start. The moment you start developing your problem statement is at the point where you reach to your change matrix and you identify potential and future concerns or even a confirmed concern. You try to tell the story why you think it's a concern, what are the supporting evidences or past experiences or references that could tell the story of that possible concern in your design review meetings. Then you will tell when and where that cause or that concern would or will show up. As a straightforward process, if you want to tell how you write your problem statement, so you start with your concern. That's where your change matrix. So you reach the point where you are doing your change matrix, and in that change matrix you identified a concern, right? Now this concern should include a problem statement that is including a failure phenomenon. How does the failure happen and what is the problem statement is, and you call that out and you cite the references or additional documents that you're using in delivering your story about that certain concern. If we take an example, there's a fuel tank wall crack that we used before at corner X and at a higher speed. The fuel tank welding line separates at higher temperatures. That's another kind of failure phenomenon. The failure in this case need to be defined when, how, and where. So we can say at a certain speed. Here he say at high speeds, then that's our when. Then he say how. You can see the wall cracks. That's how the failure phenomenon is happening. In this case, the welding line separates, and that's how. And where, that's the location of the failure. In this case, fuel tank is the location, and in this case, the tank wall is the location. So you tell your story as straightforward and as detailed as possible. Arranging the design story in your DRBFM worksheet. As we remember, we have our change point list. You have the change points in here, and you have the requirement or a function. That the first two parts are used from the change point list, while this sheet is called the A rank sheet. So this is an A rank sheet. Now you have the change point, you have the requirement or function. So I have component or change point here, I have the function here, I have the concern due to change or the failure mode here. Then I can tell what's going on with that specific part. Part A related to function 1 is having those concerns or failure modes. When and how the concern appear, I can write down the root cause analysis. Because of cause 1, cause 2, and cause 3, I think it's a concern. Then I have another function that affects that component, and I have the concern or problem statement here, and I have the causes 1 or 2 or 3 here. Now you can see here how does it affect the customer. Then you will tell if there's any related effect to the customer or suppliers or neighboring systems. Then you list that down with references as well. You cite the reference needed, so that whoever needs to learn more, he can go back to the references tab and learn more. Design actions already taken to avoid the concern, either by the engineer who's building the DRBFM process or the manager who's building the DRBFM worksheet, or even concern actions happen to avoid that specific concern, or let's say design actions already taken to avoid the concern through previous design review meetings. You took the recommendations and you did 1, 2, 3, and 4 steps, and you think those are enough to avoid. Then you will ask the design review members again if that's good enough to move forward or no. Then you will loop back in the process in order to get rid of this point and think it is a success, and you already avoided that concern, and you can put it as a no concern. Then the items to reflect the design. Any item that could be affected by your taken actions, you put them here. Responsibility and deadline, if you want to add a certain deadline to solve this concern before it is too late. Then you have evaluation by design members, what they think about your actions that you take, and the final decision as well. So that's how the process is happening in the A rank sheet, and how you include your causes and root cause analysis to the problem. And in this way, you will be ready to go back to the change matrix and update it with those actions after the design review specialists are giving you the approval that those concerns are already solved. Then you can go back to the change matrix and see which is confirmed and which is non-confirmed concerns to give a bigger picture about your product and his future performance and durability.